In this video, we're going to take a look at some more options for assignment statements. Previously, we looked at the assignment operator. It's a single equal sign that will assign the number 1 to the variable x. And if I ask what x is, it'll tell me it's the number 1. If I ask what the type of x is, it should tell me that it's an integer, int. If I want to add 1 to x, let's give ourselves a little more room here. Takes the value that's currently in x, which is 1, adds 1 onto it and gets 2, and takes the value 2 and puts it back in the variable x. So now if I print out the variable of x, the value of x rather, it'll give me the number 2. Shortcut for that is plus equals 1. I can only do this if x is the variable on both sides and it's the only variable on the right side and I'm just adding something onto it. Then this will add that number onto this variable and put it back in. So since there's already a 2 there, that should put a 3 in. So now if I ask for the value x, it'll tell me it's a 3. I can also do that with the other operators, x equals x minus 1. And now if I print out x, it's going to take 3 minus 1 is 2, put it back in x, and now I'm going to get a value of 2. And the shortcut for that is the same. It's minus equals 1, and that will subtract 1 from the current value of x, which is 2, and it will give me a 1 for an answer. If I ask for the value of x now, I get a 1. The same applies with multiplication and division. If I do x equals x times 5 and hit enter, that should give me 5. If I print out x, it'll tell me the number 5 is in there. If I do x times equals 5, it's going to take the current value of 5 and multiply it by 5, and I'm going to get 25 for a value for x. And the same thing applies to division. If I do x equals x divided by 5, it takes the 25, divides it by 5, and gets 5 for an answer, puts the 5 back in x. And if I ask for the value of x now, it's going to tell me that x is a 5. However, the type has changed. If I do type of x, it is now float. Okay? If I do, let's do this again. X equals 25. We'll go back to where we were a couple lines ago. And now I'm going to do x equals x slash 5. That is the integer division. And if I take 25 and divide it by 5 and get an integer, I'm going to get just an integer value 5. If I do the type of x now, it's going to tell me that that's an integer 5. So if I want the result to be a floating point number, I do this. If I want the result to be an integer, I do this. And note that I can do integer division. Let's do x equals 25.0 slash 5. Let's do something that doesn't go even. Let's do 25.5 divided by 5. Let's do divided by 5 first and type x, and we get 5.1. Now let's do x equals 25.5 slash 5 and hit enter. And now let's look at x, and x is 5. Because there was a floating point number on the right side, if there's ever a floating point number on the right side, it doesn't matter how many integers there are. If there's at least one floating point number over here, the result is going to be a floating point. But I'm telling it to do integer division, so it's going to give me the integer part of the result. That's the result, but the integer part is just 5. And I can also do, so let me see, x is now 5. I can do x slash equals 2, and that should give me 2.5. So that says take x, divide it by 2, and put the answer back in x. So if I type x now, I should get 2.5. So you can do all of those shortcut operators with addition, subtraction, multiplication, division. Also, you can do it with floating point division. And we've got some other operators here. We've got 2. If I want to raise a number to a power, let's do 2 to the 3rd power should give me 8. I didn't put that in a variable. If I want to save it to use later, now I've saved it in the variable x. So that is our raising a number to an exponent. Now let's try a few more things. Let's do pay rate. $10 an hour. Hours equals 40. And pay equals hours times pay rate. Let's see what pay is. It should be 400, and it should be a floating point 400. Because pay rate is floating point. Okay. Now, if I do pay rate 20, it changes the value of pay rate. It does not change the value of pay. Okay, it doesn't go back and recompute this again. Computers execute instructions sequentially, and since this was executed after this was executed, then the value of pay does not change. So if I look for the value of pay now, I should still get 400. If I go back, I'm going to hit the up arrow key so I don't have to retype that command again. So I hit the up arrow key 4 times. And pay equals hours times pay rate. Now I'm recalculating the value of pay. Hours is still 40 up here. Pay rate, the most recent value of pay rate was assigned to be 20. So I'll take 40 times 20, and I'm going to get 800 instead of 400. So now if I look at the value of pay, it's 800. Okay, we have the usual precedence rules for arithmetic. Anything in parentheses is done first, then multiplication and division from left to right, then addition and subtraction. This is exactly what you learned in all of your math classes from left to right. So I'm going to get an error when I do this because that doesn't make any sense. But that is the priority rules, the precedence rules for doing operations. Now, normally you do from left to right if I have things at the same level. So if I've got some multiplication division all in the same expression, I just do the multiplication division from left to right. Okay. Same thing with addition and subtraction. I just do them from left to right. There's an exception to this, though, and that is raising a number to a power. If I take 2 to the second power, okay, so 2 to the third power would be 8, and 8 to the second power would be 64. Okay, so let's hit enter. And I do not get 64. The reason is because this is done right to left. So it takes 3 to the second power, which is 9, and then takes 2 to the ninth power, which is 512. So that is the same as 2, whoops. If I want to override that, and I want to take 2 to the third power first, then this is a place where you have to use the parentheses. So 2 to the third, and then take that answer, that's going to be 8, and square that, and I should get 64 for an answer. Okay, so that's the one exception. Just remember, that doesn't happen very often where you're raising a number to a power and then you're raising that to a power, but keep that in mind. Okay, let's try a few more that demonstrate some precedence here. If I take 2 plus 3 times 4, the multiplication is going to get done first. I'm going to get 3 times 4 is 12, plus 2 is 14. If I want to do the addition first, I got to do 2 plus 3 first and multiply it times 4. It's going to times 4. It's going to take 5 times 4, and I'm going to get 20 for an answer when I do that. Okay. You might be tempted to try to do what you did in algebra class, 2 plus 3, and put a 4 there without an operator. We're going to get an error when we do that. Okay. Let's try this one. 2 plus 3, that's going to be 5, times 4 to the second power. Okay. This is going to get done first. 4 to the second power is 16. I'm going to multiply it times 5, and I should get 80 for an answer here. So it's not going to take 2 plus 3 is 5 and multiply it by 4 and get 20 and square that, which would be 400. So if I wanted to do that, let me use the up arrow key here again so I don't have to retype. I would have to say, okay, we'll do this first and then raise that answer to a power. And now I get 400. Okay, let's look at a few more examples here. That looks like a number, but it's got apostrophes or quotation marks around it, so it's actually a string. If I do type of, tells me it's a string, even though it looks like a number. Looks like a float, but it's a string because I've got quotation marks around it. Okay. If I want to, let's do S for string. S equals 5. Okay. And if I want to convert that, there's a built-in function called int. And if I ask for the integer value of S, it'll come back and it'll tell me 5. There's also a float. If I ask for the floating value of S, it'll come back and give me 5.0. So if what's inside the quotation marks of the string is a valid number, either a floating point number or an integer, you can easily convert it by using the int function or by using the float function. Okay, let's take a look at some of the options for division here. We're just going to type a bunch of division problems. 9 divided by 4, that's floating point operator. And even though 9 and 4 are integers, I'm going to get a floating point answer because of the slash. If I do 10/4, I'm going to get 2.5. If I do 11/4, I'm going to get 2.75. 12/4 is going to be 3.0. That's still a floating point number. It just has a decimal portion with a value of 0. Now I'm going to do integer division on some of those same problems. 9//4. That's going to give me the integer value, which is just 2. I do 10//4. Still going to get 2. 11//4 is still 2. 12//4 is going to be 3, though. Okay. And it turns out that you can do that. You can do integer division even with floating point operands. So if I can do 9.0//4.5, I get an integer 2. Now it'd be integer 2 or floating point 2 no matter what. There is no decimal part. But if I do 9//4.4, that goes in there 2 times with a little bit left over, but I'm still just going to get a floating point 2. Floating point because one of my operands is floating point. There is a 0 after it, though, because I'm doing integer division with floating point numbers. Okay. And the last arithmetic operator we're going to look at is called the mod or modulo operator. It gives you a remainder. So let's do 8. And it's the percent sign. It has nothing to do with percentages at all. It's just a symbol that they found on the keyboard and said, we're not using that for anything else, so we're going to use it for the mod operator. That means divide by 4 and take the remainder, which is going to be 0. Okay? If I take 9 and divide by 4 and take the remainder, I'm going to get 1. If I take 10 and divide by 4 and take the remainder, 10 and divide by 4 and take the remainder, I'm going to get 2. Okay. And also, if I do 10.5 mod 4.0, I get the remainder is going to be 2.5. Okay, so it goes in there 8. 4 times 2 is 8. And if I subtract 10.5 minus 8, I get 2.5 for the remainder. Okay. And we're going to do exponents here. 2 to the second power is 4. And we're going to do 2 to the 10th power, which is going to be 1,024. We're going to do 2 to the 20th power, which is 1,000,000 and something, but that's a little bigger than I can memorize. 2 to the 100th power. 2 times itself 100 times. And that's what I get. Let's see how far we can go with this. 2 to the 1,000th power. It's a big number. How about 2 to the 10,000th power? Whoops. And I don't know. I think that's pretty impressive. That's a big number, and Python did it just like that. The last example we're going to do in this video shows a useful application of both integer division and the mod or remainder operator. So let's do a variable called minutes equals 645. Okay. Well, 600 minutes would be 10 hours, and the 45 would be minutes left over. So that's 10 hours and 45 minutes. Okay. Now what I want to do is I want to figure out how many hours that is. So hours is going to be equal to minutes. I want to do integer division. I want to find out how many 60s there are in that. And hours is 10. Then I want to, if I divide that by 60 and take the remainder, that'll tell me how many minutes are left over. So minutes equals the current value of minutes. I'm going to wipe out the 645 here. Mod 60. Okay, and if I ask for the value of minutes, it comes back and tells me it's 45. So if I do hours and plus, I might get an error here when I do this. If I want to print that out using the colon symbol in between, which is what we usually do, I get an error. And it says I can't add unsupported operand types for the plus operator. I cannot use an int and a string with a plus sign in between. They either both have to be ints, in which case it'll do addition, or they both have to be strings, in which case it'll do concatenation, tacking strings together. So if I do string of hours, and then say, that just made it into a string, and then tack on a colon, and then take the string value of seconds, and hit enter. I'm sorry, I should have said minutes. Now let's try it. And it prints out the string 10:45. That works pretty well unless minutes is a one-digit number. Now if I'm going to hit the up arrow key twice, so I don't have to retype that command. Now if I print that out, I get 10:5, and that doesn't really look the way we're used to seeing it. We're used to seeing a 0 in front of that. So when that happens, we have to make a decision about whether that number for minutes is less than 10 or not. If it's less than 10, we need to stick a number 0 in front of it. If it's not less than 10, we can just print it out the way it is, like we did up here with the 10:45. So to do this requires making a decision. Making a decision requires learning about something called the if statement, which we will cover in a future video.